It is really a great honor to receive the Helen Keller Prize for Vision Research. And it's a special privilege to follow in the footsteps of such distinguished previous Helen Keller laureates. I'm very gratified also by the opportunity to accept the prize in the presence of so many outstanding ophthalmologists and good friends. Upon hearing or learning that I was to receive the Helen Keller Prize, I could not help but reflect that my affection for your specialty is because I have had a rather unique apprenticeship extending over 30 years in a subspecialty called experimental ocular neovascularization. And this apprenticeship has had many teachers. And then undergraduate and graduate students came to the lab, many of whom went on to become ophthalmologists. The most recent is Lucy Shen, whose paper here this morning on diabetes and rosiglitazone was presented from work based partly in our laboratory. And then came outstanding postdoctoral fellows and young faculty, including Patricia DeMori and Bella Apte and Robert D'Amato and Tony Adamus and Richard Casey and David Chima and many others. And these ophthalmology teachers to whom I was in a sense apprenticed were themselves witnesses to the early development of the field of angiogenesis research. They were there when it wasn't working and then it was working. And they saw how discovery of the first pro-angiogenic proteins and discovery of the first anti-angiogenic proteins depended critically on a model of corneal neovascularization in the rabbit and mouse eye. I think without the cornea, there would be no field of angiogenesis with its current 27,000 papers worldwide. And they also saw Robert Langer, a young chemical engineer from MIT, postdoc, convert the polymer of soft contact lenses, polyhydroxyethyl methacrylate, into a slow-release polymer for proteins. Nobody had ever released proteins before, and he could implant it in the cornea without any inflammation. And they saw how this in vivo model, used in conjunction with other bioassays, such as endothelial cells that didn't even exist before 1972, led to the identification today of a family of pro-angiogenic and anti-angiogenic molecules. Of the more than 50 known inhibitors of angiogenesis, the cornea bioassay made it possible for us to discover at least 11 of these over a period of 20 years, starting in 1980. And today it is known that there are at least 28 angiogenesis inhibitors in the blood. None were known before 1980. My favorite grant rejection is in 1979 that said, we were trying to find an angiogenesis inhibitor, that said the existence of an angiogenesis inhibitor is only in the mind of the principal investigator. And 15 years later, Harvard used that to settle and win a patent dispute because they said the government itself couldn't see it. And it taught us a lesson that you should save all of your grant rejections. Well, these angiogenesis regulatory molecules, when they were fully sequenced, and in most cases the crystal structure identified, and then the gene isolated, and then the recombinant proteins made, finally caught the attention of scientists around the world. For example, in 1971, there were only 3 papers on angiogenesis in the world literature, which runs every week, at least 30,000 papers. And 2 of these were from our lab, and one was criticizing a former paper of ours. But today, there are more than 70 to 80 papers on angiogenesis every week. Well, finally, by the late 1990s, the pharmaceutical and the biotech industry began to believe. Everyone has beliefs, surgeons, clinicians, scientists, that anti-angiogenic drugs could be actually manufactured and tested clinically, and they also recognized that many non-neoplastic diseases are angiogenesis dependent, including atherosclerotic plaques and endometriosis and psoriasis and rheumatoid arthritis and uterine fibroids and benign prostatic hypertrophy, but especially macular degeneration and diabetic retinopathy, because these have such large populations. So today you can write a prescription for 9 different angiogenesis inhibitors in the US and abroad. But to my mind, one of the most exciting clinical applications of anti-angiogenic therapy has been the treatment of age-related macular degeneration, as you all know. And in December 2005, the most interesting thing is that Nature published a 35-page summary of the field. We don't even have a paper in it, it's just published a whole summary that concluded with this statement, quote, "In the next decades, more than 500 million people worldwide are predicted to benefit from pro or anti-angiogenesis treatments." If I had said that, no one would believe it, but Nature said that, so I can quote it. In summing up, during the long years of laboratory work that led to the advances which I have tried to give you a glimpse of, I began to ask the question, how do you know when to keep going or when to cut your losses in research and start a new direction? How does one make this decision to persist when all the experts are insisting that it is futile? And we have much evidence for that. And there seems to be a very fine line between persistence and obstinacy in research. For the failure of the thwarted researcher who is called in the promotion committee obstinate, inflexible, stiff-necked, bullheaded, wedded to a theory, and I've heard all these sitting through these committees, or worst of all, pig-headed. The English language has more words for stubbornness than any other language. The key to avoiding this fate seems to be to choose a problem that is worth persistent effort. Edwin Land, the founder of Polaroid, put it in the strongest words when he said, "My personal philosophy is never to undertake a project unless it is manifestly important and nearly impossible." This is precisely the way angiogenesis research seemed to me when I began this journey more than 35 years ago. So I am deeply grateful to the award committee of the Helen Keller Foundation for their confidence and for the fact that they have put their imprimatur on the value of persistence in proving new ideas. Thank you very much for this very wonderful award.